Welcome back to the PhoneGap Essentials course on NetTuts Plus Premium. In this lesson we're going to explore the Accelerometer API. This API gives us access to the native device's accelerometer, which allows us to capture motion in X, Y, and Z directions. We'll be using the accelerometer.watchAcceleration function. This is essentially a function which is called periodically. That is, you can decide how often it is called and how often you want to get updated accelerometer information. It requires an onSuccess function, an onError function, and can also be passed options, such as the frequency or how often you want to fire the event. The success function gets passed an acceleration object. This contains the acceleration in the X, Y, and Z direction, and also a timestamp. To detect orientation change, such as when a user moves their phone from the vertical position to the horizontal, we actually don't use a native API. For that, we can simply use the onOrientationChange event that is native to the browser. So let's get started. I'll open up index.js and put a call to start acceleration watch. We're going to set some options. Well, just one option, the frequency. We want to take a reading of the accelerometer every 100 milliseconds. And now we can start our accelerometer watch. I've attached the watch to a watch ID, which I'll define up in the initialize function. This way I can stop the accelerometer whenever I want. The accelerometer command is accessed through the navigator, accelerometer, and requires three parameters: the success parameter, the error parameter, and the options. Let's define our success and error functions. Our onSuccess function will be called and will be passed the acceleration object. For now, we're going to write the X, Y, and Z acceleration and the timestamp directly into our test zone inner HTML. And if there's an error, we'll write acceleration error into the test zone HTML. If we launch the emulator, we're going to get an acceleration error because the emulator does not have an accelerometer. To test it, we'll have to launch to device. Here you can see the acceleration values being written to the test zone div. You'll notice that acceleration Y is about 9.6, 9.8. This is a representation of the force of gravity on the Y-axis. If we turn the device onto its side, you'll notice that the X value is now about 9.6, 9.8. Printing some numbers to the screen, however, is not very exciting. So let's comment out this debug information that we're printing, and instead we'll use our accelerometer to move a smaller div inside the confines of our test zone div. So now on every update of the accelerometer, we're going to print this div with the class of block inside our test zone div. Let's go to the CSS file to make sure it looks right. I'll create a new style for it. And we basically just want to create a white block 50 pixels high and 50 pixels wide and position it in the middle of our test zone container. You'll notice that test zone has had position relative added to it, so that with our block we can use absolute positioning. So here we are with all of our styles added in: width, height, position, absolute, and then left 50%, top 50%. This will put our block in the middle of the test zone div. So the block will now be in the middle of the test zone div. We can now use the accelerometer information to adjust its position within that div. We can offset his position using top and left margin. We're going to base our left margin off the acceleration.x value. I've set it to negative so that the block will appear to move in the right direction. I'm going to times this number by 20 As we saw before, the maximum acceleration value was 10. This means that the maximum distance our block can move is 200 pixels. And I'll do the same for a variable called margin top, which will be based on the y acceleration. We can then add these values to our block using the style attribute, and we'll add them in as margin top and margin left CSS values. As you can see, style margin left equals the margin left variable we created, and margin top equals the margin top variable we created. If I export to device, you can see the block now moves around the screen based on the phone's orientation. A lesson on the accelerometer would not be complete without looking at orientation change. For mobile devices, it's very important to be able to understand when a user has changed the orientation of the device, so that you can change layout elements and the arrangement of information accordingly. Now, before we set up an orientation test, we're going to have to clear up our test zone HTML. We're going to stop the accelerometer watch first, and then clear out the inner HTML of test zone so that we can do our new orientation change test. So that we can decide when we want to initiate this test, we're going to add an event listener to onDeviceReady. It's going to be a click listener on the app.testzone div, and we're going to call a function called app.testOrientation. Here's our test orientation function blocked out. The first thing we want to do is stop the accelerometer watch. We'll create a new function called stopAccelWatch. Then we're going to want to add an event listener to listen to orientation changes. The event listener to listen to orientation changes is not actually a PhoneGap event. It's a native browser-based event. So you could use this one in a web page being browsed by a mobile device. This will call on orientation change. Let's block out those two new functions. So here are our two functions. Let's start by shutting off the acceleration watch. We use the function navigator.accelerometer.clearWatch, and then we have to pass in the watch ID that we set up when we started our watch. Now that we've cleared our watch, we can handle our orientation change. As always, we're going to be updating the test zone inner HTML, and we're going to be updating it with the window.orientation value. As you can see, this orientation value is not being passed with the event, but is actually attached to the window. So we find out that there's been an orientation change, and we get the value directly from the browser or the internal PhoneGap browser window. But before we do anything, we should just fix up this little typo. This should be stop AccelWatch. And let's clear out the test zone div. We'll set it equal to an empty string. So let's go and export to device and have a look. So as you can see, it's behaving just as before, with the little block moving around the screen. And when I tap the screen, the block goes away. Now if I turn the screen, and we have an orientation change, we'll see we're presented with a number. 0 degrees in the case of vertically straight, 90 when it's on one side, and -90 when it's on the other side. That's all for now. If you'd like an extra challenge, why not try detecting a shake gesture using the accelerometer? On Mobile Tuts Plus, there's a great tutorial called PhoneGap from Scratch. The second part of this tutorial, Device APIs, has a section where it shows you how to detect a shake gesture using the accelerometer. The basic theory is that as you read in each value from the accelerometer, you store that reading in a variable called previous reading. You can then compare previous reading with the next reading, and if there was a great change in the accelerometer values, it means that somebody shook the telephone. Check back in for lesson 8, where we'll be talking about the geolocation API. Ciao!